So the theories or models that try to explain why individuals with right hemisphere damage have the problems that they do are relatively young and in the early stages of development. So this is still an area that we don't know a lot about, particularly, for example, compared to, I think, persons with aphasia and the problems of aphasia. There are a few hypotheses that are out there that are perhaps all true. They're not necessarily in conflict with each other. One hypothesis is that these problems represent impairments of basic elements of cognition, like attention or working memory. Right? So problems understanding a discourse is a result of attention or working memory problems. And there's a logic to that, because discourse is a lot of verbal material that we have to follow. And so if we have poor attention, we can miss key points in a conversation. If we have poor working memory, we may not be able to hold all the information in mind until whatever point a person is trying to make is resolved. So there's that. There is also a theory called the coarse coding hypothesis. And the coarse coding hypothesis says that the right hemisphere is kind of responsible for activating and maintaining the secondary or unusual meanings of words. Right? So, for example, if we look in our dictionary for the definition of apple, we're going to find some kind of prototypical attributes being described. An apple is red, it grows on a tree, it's sweet and tart, it grows in colder climates, etc. We may not see in that definition some secondary definitions, or not necessarily definitions, but words or attributes, semantic attributes that are also associated with apples. For example, the attribute of good, right? In other words, he's a good apple. Or rotten. An apple can be rotten. He can be a rotten apple. So there's a sense, again, that the right hemisphere activates the connotative nature of words. This activation of the connotative nature of words, or the distant meanings of words or distant associations, allows us to understand more non-literal language. It allows us to understand what's being implied by what a person says. Dr. Connie Tompkins, who I consider one of the world experts in right hemisphere communication disorders, gave an example in one of her papers. She said, imagine a scenario, something like this, where someone said, when Sue called the lifeguard for help, he saw broken glass. Now, in the course of a conversation, there may be an implication, for example, that Sue may have cut her foot and was bleeding, right? Because swim or lifeguard has a connotation with swimming, being barefoot, broken glass can cut. There's a related connotation of, or association with bleeding, etc. And so we do this a lot in conversation, though we're not aware of it. And in other words, we don't spell out everything necessarily. And so people with problems of coarse coding might have difficulty, again, with the implied meaning of what someone is saying, particularly if it's non-literal figurative language. Another hypothesis is the suppression deficit hypothesis. And that says that, and it's somewhat related to coarse coding. It's saying that when, for example, I'm listening to someone speak and I hear words, that all kinds of associations are activated by hearing those words. But that some of them are not appropriate to the context of the conversation. So if I hear a farmer talking about his pens, right? Well, in the context of a conversation, I may not want to activate the concept of ink pen, right? Because he's talking about his pig pens. So not suppressing, or let's say probably what happens just as often is slowly suppressing, right? Because of course this suppression happens, we're talking difference of milliseconds from normal individual to someone with right hemisphere damage, but those small differences and delays slows processing and comprehension for people with right hemisphere damage and can place additional cognitive load on them. And of course, if they already have problems with attention and working memory, you can see that this starts to add up with, and they have coarse coding problems. In other words, they're not only not activating all of the associated meanings that might be needed, but they're having difficulty suppressing meanings that are not appropriate. This places a big cognitive burden on them. Processing is slowed. And they miss things, or they misinterpret things in the course of a conversation. And that's why we see problems at the discourse level. When material is short, like understanding one simple sentence, of course people with right hemisphere damage don't have a problem. The final hypothesis that's been used to describe the kind of problems that individuals with right hemisphere damage have in terms of communication is the pragmatic deficit hypothesis. And pragmatics, as you know, refers to the context appropriate use and interpretation of language. And as we'll see later, a lot of the kind of symptoms of right hemisphere communication difficulties, a lot of these symptoms are pragmatically related problems. And there have been some who have proposed that individuals with right hemisphere damage have a problem with social cognition, or if you're aware of theory of mind, which has been used to describe some of the problems that people with autism have. But I think if we look at the idea that these individuals have cognitive difficulties, particularly attention, that there may be this poor ability at coarse semantic coding, activating more distant meanings or attributes of words, difficulty suppressing irrelevant information. You can see that these are deficits that will very much interact with a person's ability to hold a socially appropriate conversation. And as we'll talk about later, there are other problems associated with attention, such as picking up nonverbal cues of emotion and helping and that information helping us interpret what people are saying and interpret their intention, etc.